Hello and welcome to this new tutorial about encryption. In order to send a message, if it's in plain text, it will be readable by anyone who knows how to sneak in and see the messages that are sent through any media. So in order to learn how the encryption works, we are gonna talk about Caesar Encryption. That it's the easiest way of encryption, and this is used just for educational purpose. There are many different types of encryption, and we are talking about the easiest one, and this is Caesar Encryption. So in Caesar Encryption, we shift the alphabet or the characters some steps either forward or backward. Let's see. The letter A is there's a number corresponding to each letter. So the capital letter A is equal to 65 in the computer world, and the letter B is equal to 66, and letter Z is equal to 90. And in the same way, letter small a is equal to 97, B 98, and Z 122. So let's see how we show it that these letters correspond, these numbers correspond to these letters. So we check that there are two built-in methods or functions that we can see and in order to check. So if we want to check that we want to print it, we want to check if which number corresponds to the capital letter A. So let's run it and see what it shows. It shows 65. Okay, so as we said, it shows 65. And let's see if we letter Z, capital letter, so see it shows 90. Okay, that's good. So it shows the order of the letter and the corresponding number. And if we have, for example, if we have one, if we the other built-in, we write a character, and in this case we have to write a number here. For example, 115. Let's see which character is this. Character 115. Run it and see it is S. Okay, if we have, for example, 70, count 65, and it will be a capital letter. So let's see what it's AF. Okay, so like these, we know that which letter corresponds to which number, or which number corresponds to which letter. Okay, so now we come to how to make a function in order to be able to encrypt a text, a plain text, in order to send it to someone safely. So we define a function, we call it Caesar Encryption, and we have an in parameter which we can call it text. We will have a text here in order to be passed in this when we pass in an in parameter. So we have to return a ciphertext or an encrypted text. So we will introduce a ciphertext, a variable by the name of ciphertext, and it's empty. It doesn't have anything, it's just empty. So what we do here now, we go through the text that we get, this text, and each character is converted to the number that they correspond to. We change the number and then change them back to the character and put them beside each other. So let's see, we we iterate by a for loop 4. We write char as character. So this character is the every character in the text. In text and text. So we go through each character in this text that we get. So what we do here, we get the number, we get the char number, we get the character number of each character. So what we do, we as we said here, introduce this built-in message, and here we have to have this character. This character that we are talking about, each time a new character from the text, we go through that, change it to the number, because and this number is the number. For example, if it's an A from at the beginning, so it will change to 65. So this number will be 65. And what we do, we have to change this number to shift it either forward or backward. So we shifted one step forward. So we write new character number. New character number. So this will be the new number, and what we do, this we have this character +1. So we change +1 or +2. It's up to us how many steps we change this. For example, A, in this case, A will be B. A will be converted to B, and B will be converted to C. And then what we do, we place, so we change it back to a character. This was here we had a character, we changed it to the number, and then changed the number to a new number, a shifted number. Now we change back the character, so we write cipher character, the character that has been changed, that has been encrypted. So this will be the this char and this new number. So in this case, the new number, by this new number, we get a new character. We get a new letter. That is our cipher character, or that's our encrypted character. So now what we do, we concatenate all the characters that we get into this ciphertext, so that we build a new text by this in this way. So now what we do, the ciphertext is equal to ciphertext plus what? So plus what? We plus it with the new cipher character, with this one. So in this case, every time we get a new character, change it to the number, and the number will be shifted one step, and the number will be changed to character, back to character, or back to the new letter, and then we put it inside this ciphertext, or the encrypted text. So at last, when we go through all the whole text, so we have to return. We have to return what? Now we are outside the for loop. So now it means that we have gone through the whole text. So now when we are outside the for loop, so we have to return. What we have to return? We have to return this ciphertext that has been is full of a new text, cipher or encrypted text. So in this way, we have built a new ciphertext, or we have encrypted the text that we got from the beginning, from the user. Okay, let's check it if it works. So what we do, it does not work if I just write the name of this like this, and we write, for example, hello. We write hello, it will not work because it returns. And now we have to print it in order to be able to see it. We print it like this, and let's see what it gives the result if there isn't any mistakes. So it's encrypted to IFMMP because there is a double L, and double L is equal to what comes after L comes F. So these two double L's are changed to M, to double M's. And after O, in OP, after O comes P, so O is converted to P, changed to P. Okay, that's good, so it's working. Now what we do, we change this to 3. So we shift these characters 3 steps to the right. So each A will be 3 steps, changed 3 steps to the right. So B, C, D. So A will be converted to D. Now let's check it again and see how the encrypted text that is like this one step, and now let's see. Aha, so this is changed to this. So this is not readable for any person who does not know how to decrypt it. So it works. And now in order to make it a little bit easy, because we cannot just change how many steps we're going to shift back and forward and so on. So it will be better, in order to change this method, to be able to enter the shift steps in the method itself. So now what we do, we introduce another parameter here. It will call it shift. We call it shift. So this shift, how many steps we shift the text to the right or to the left. So now instead of this shift, instead of this 3, we write the shift. So what in this case, what we do, that we tell the user tells the computer that how many steps should we shift this. For example, I now in the method I have written hello, and I shifted to 2 steps. So let's see how it works now. That's good. So now we just very easily can change it here in the method, 5 steps. We shift 5 steps and see this new text. So and one thing else, that we can change this method, or we can use this method for both encryption and decryption. If we, for example, we write hello and 5 steps, we change it 5 steps, so we get this. And if I copy this text, and what we do, let me copy this first here, and then I print it, and I print the ciphertext that we got. And what we do, I print it here like this. And if I go 5 steps backwards, if I have this ciphertext and I go 5 steps backward, for each letter I get the letter that the text that I got from the beginning. So it means that with like this, if I write -5, it means that if I know the number of shifts that I have done, so if I go 5 steps backward, I'll get the same letter. So now this will give this ciphertext, and this method or function will give the hello. So let's see if it works. Now we see that both methods, the first method, the first function, we have a hello, and we shifted 5 steps, so we get this. And in the second one, we see that we have this encrypted text. We go 5 steps backward, and we get hello back again. So in this way, we can use the same shift. For if we know the shift number of shifts, we can use it for both encryption and decryption. So in this case, in order to clarify this for the user, so we write positive shift is used for encryption and negative for decryption. So positive, when we use positive numbers, it depends on the text. If we have gone backward from the beginning, we have to go forward for when we decrypt it. So it depends on how we have encrypted the text. So we use either forward or backward. So this is the Caesar encryption. I hope you have learned something, and please subscribe and share if you haven't done that, and wish you happy coding.